Thank you, everybody. Thank you guys for coming in person. Such a small crowd, but that's okay. Thank you guys for jumping online as well. I wanted to just to go through a couple things and as we get started. Now it doesn't want to do it. There it goes. Okay. So first things first, this is still considered an association event, CRMCA. We do follow regulations and antitrust, not talking about each other's company's prices, competition, really bottom line. So we want to keep that in mind as these guys present on the information today. They're going to talk in more general, not specific products. So I just wanted to keep that in mind. If you guys are not members of the CRMCA, we do have information as well as benefits for that, specifically ACI on a technical standpoint, as well as involvement in the technical committee as well, where we do discuss a lot of issues in regards to the local processes and policies that run through many organizations, the municipalities, CDOT. Just today, right before this presentation, we did have our technical committee, and we talked about one specific thing that we're going to be talking about over the next several months as well. So if you guys want to get involved, please do. Want to say thank you for the sponsors of the Technical Tuesdays, Burnco, GCC, Creso, and Wholesome for their support of this series. So thank you to those guys. And with that, we'll jump right into the concrete flatwork finishing problems and possible solutions. These guys are going to be talking about really flatwork, what you're going to be seeing out there, what some of those solutions are, how you can really avoid some of the stuff going on. We've got George Herrera over here, or Jorge, depends on who you talk to. He's the quality control manager down in Colorado Springs for Burnco. And we also have Ralph Marmoledo he's the quality control foreman with Loveland Ready Mix. So both these guys are going to be presenting that, and I will hand it off to them and let them take forward. And if you guys want to talk about how you want to take questions and answers, go for it.
Perfect. Yeah, feel free to say, like I said, if you have any questions online too, if you guys want to jump in, let us know. It's a conversation that we're going to have about, the effects of finishing and issues that you might experience, and how to get over them, how to fix the stuff. So there we go. Jorge, ready?
Yeah, let's do this. So obviously the first thing we want to talk about, which is pre-con meetings. This is hugely important because this gets everybody on the same page. So this is kind of an example of everybody should be involved on me. We also know how incredibly busy we get to this time of year, right? It's not always feasible for everybody in this group to be involved. But at some point, some part of this group should be in a pre-con meeting. You may not be able to get necessarily general contractor, but maybe you get the flatwork contractor for that meeting, that sort of thing. Maybe you have inspector, but not third-party testing company. But so we want to see some kind of variation of these people in a pre-con meeting, just so everybody's on the same page day one. Everybody can relay that information according to, what part of they play in the construction. So that's vitally important for that.
That's, definitely you want to have at least general contractor or the flatwork contractor, same page with the engineer, so he knows exactly what, what's being ordered, what's going to be being placed, how many PSI, and then you definitely want to relate that to the concrete producer, so it's good to have these at least big part of this group in there. It comes down to that.
Obviously, the goal is as many of these people as we can get involved is the best way to go. To that though, when we're having the pre-con meeting, these are some of the things that we should be discussing, not only for the concrete, but also for just safety. One of the big ones is, do we have enough space for trucks to come and go? Is it a big wide open field? Do we have a really narrow, path? Do we have good traffic control for that sort of thing? For me, this is a personal thing because I am in QC, and my biggest question is always like, who's allowed to have the water to the concrete? Is it, you know, do we have a pump out there? Is the pump guy allowed to say, hey, we're gonna add the water? Is it just the QC? Is it just the concrete contractor? For in my world, that's wildly important, right? We wanna make sure that we have enough crew, you know, if something comes up where we end up getting stacked with trucks, do we have enough crew to handle that? Do we not? And then some of the things that we want to be prepared for, excuse me, if we have an emergency, you know, if equipment breaks down, do we have a backup pump on site, things like that, of that nature. These are some of the big things that we want to discuss, you know, involving the delivery of the concrete in those pre-con meetings.
Definitely, if you have your form set, you have enough crews, the spacing too, you know, what all that stuff, like I said, it's very important for the delivery of the cement, of the concrete.
And then, I mean, this is some of the things that, you know, should obviously be planned for and prepared for and just discussed also is, again, the adjustments to the mix. If we need to have a, you know, hey, we are allowed a higher slump, we don't want to destroy the water cement ratio though, can we get this in chemical form, that sort of thing, so have that kind of conversation with the producer, hugely important. You know, we're very adaptable to seeing changes made, so long as we know what those changes look like. Then the subgrade preparation, this is a conversation that we were having earlier is, you know, what does a subgrade look like? Is it gonna be on dirt? Is it gonna be on rock? Is it gonna be on a vapor barrier? You know, that's important for us to know because that all changes what this concrete is gonna do when we put it on the ground. Are we sloping it right? Are we pushing it away from the building? Do we have walls in that subgrade, things like that? And this is actually a great point that Raul brought up as we're discussing when we're talking about reinforcement. If we have steel reinforcement, do we need accelerator? Are we making sure that that's a non-calcium accelerator to avoid any kind of issues with corrosion? Hugely important, you know.
Calcium does corrode when it comes down to your rebar. So always keep that in mind if you're gonna be using, you know, reinforcement and you're gonna be using accelerators, always go to the NCA route. Calcium will corrode it and you'll have issues later on that line.
Absolutely. So with this is some of the problems that we're gonna be discussing today that we're, you know, I'm sure a lot of you have seen happen already. But these are some of the things that we're gonna be talking about, you know, what we're starting to see as far as things like the bleed water and, you know, kind of what we can do to help that along. As far as the different kinds of cracking, I'm not sure if any of you guys have started dealing with sticky concrete. That's something we're gonna be discussing now as well. Kind of get into the nitty gritty of a little bit of these. So if at any point you guys have any thoughts or questions on any of the ones that we have up, please feel free to, you know, pop your hand, throw it out there.
Yeah, based on what Jorge said is, you know, anticipate problems. We are working with the new material. It's our 1L product. It is a thirsty cement.
Yeah.
It will need more water than what we're used to seeing. So that's where we will focus on the slow and more slow setting than fast. We are gonna focus on some of the issues like blistering, delamination, crazing, curling, scaling, because it is, like I said, it is very prone based on the amounts of water that are being used. So we'll talk about it. And if you guys have any questions, like I said, please jump in.
So I'm sure most of you guys have seen this, right? Our window finishability, our little timetable. I know some of you may be thinking something's missing here. We did actually pull out the time frame for the window finishability because, as Raul brought up, the new materials in the world are changing that window finishability. It used to be, what, 1 to 3 hours, I believe, was the standard kind of expected. Well, now it very much depends on the mix that you have. You know, if you have something that is got 20% replacement versus, you know, no replacement, that's gonna shift that time, that window of finishability. So we've just kind of narrowed it down to, hey, that window of finishability is from gold flow to troweling, power troweling. That's what our window looks like. What that it looks like kind of depends on the mix. And so it's kind of changing in the new world. Because like Raul said, you know, the new 1Ls, the NPs of the world, these things are becoming more refined, so they are taking up more water. They're shifting the way we're doing things.
So it definitely bleeds a lot slower than what we're used to seeing, well, previously.
Absolutely.
So what we always recommend, and we recommend to DCs is wait, that little waiting time, there's really not a specific amount, but we always tell them, if you can walk on it, wait just a little bit longer than that. 15, 30 minutes, even up to an hour can make a difference when it comes down to doing the power trolling.
Yeah, and again, what the rule of thumb is, if vegetation is a quarter of an inch. If you see that quarter of an inch, give it an extra 15, 30 minutes, an hour if you can. Just because it is a slower, more fine material that we're using now. That's a rule of thumb that we've kind of come to at this point, with the new materials we're seeing.
Any questions on that?
So you're saying this new cement, you said it's thirsty, it takes more water, but at the same time it bleeds more slowly?
Correct.
Yes.
Yes, it takes more water, and that water is gonna have to come up somewhere. Usually comes up to that top part, so it does take a little bit longer than previous cement materials that we've gotten used to using. So a lot thirstier.
Yes. So actually, to that point, one of the things that, this is a great image of excessive bleed, or an excessive bleed water, right? This is maybe something that we've seen in the past. This is something we're seeing less and less of moving into the world of 1Ls. Because it is a finer material, we're seeing less bleed water coming through. This is still a vital part of the finishing process though. So when we are seeing bleed, we wanna make sure and give that a little extra time because it does take a bit longer than it used to with the 1L versus the old 1-2 that we kind of have seen over the last 30, 40, 50 years, right? Things like that. So the big thing is we wanna make sure we give it that little extra time because we all know that we have to allow that bleed water to evaporate. We're working into that surface, we're just ruining the water cement ratio on the top. So we're suggesting that you take that little extra time to make sure we have all of that bleed water come through and allow it to evaporate instead of just that first initial shot of it.
Yeah, I always tell them, do not work in that bleed water into the cement or into the concrete. It creates things like one of the main issues is like dusting. And we'll talk a little bit more about dusting when we get back into that, but don't work it in.
And so this is a great example of what, this is a great
Good
looking, great, we were just talking about that. This is a great picture of what, the slab should look like until you get to the very top of it. When we start seeing that bleed water worked into it, and we're gonna start causing that, the strength is gonna be out of it. We're gonna start to see these things like blisters, dusting, things like that.
The surface of the part
Yeah.
is really weak, and that's where you start seeing the, like I said, the lamination, start seeing scaling, dusting, all that good stuff,
And I mean, honestly, just today, you're gonna start to see strength come down as well. So, if you're working it into the top and you go to break that cylinder, it has all that extra water on the top, it's gonna pop right at the top and you don't know what the actual strength in place is, but that top layer is ruined. We're breaking low and now we have bigger problems, right? So just some things to kind of think about. So with this, these are some of the, obviously the most common issues that cause that excessive bleed water. High slump when we're using that water, because clearly that water's gotta go work its way through somewhere, right? So if you're adding that water to that, to get that slump, you're gonna end up increasing the bleed water, or the bleed water, and you're gonna end up increasing your time. Cause it's still gotta work its way through, it's still a finer material, still 1Ls, things like that. So we're now, instead of, 30 minutes of waiting, we're now hour and a half of waiting. So for me, it's really important to know, hey, we want 6 inch on the floor. We need to get a 6 inch on the floor and to have that conversation with the producer. Cause if you need that 6 inch on the floor, we can do that. If you're wanting a 6 inch on the floor and you're ordering a 4 inch, you're now increasing your time, costing yourself more money, causing yourself more problems. So that's why for me, one of the biggest things is the conversation to have.
You gotta talk to them also about that water to cement ratio,
Absolutely.
So if you blow past that, you're basically taking strength away from your concrete.
Yeah, I mean, we personally just did a test on this, for driver training, and we showed them that breaking the water cement ratio to what they thought was, hey, this is a good place to be. We took away 25% of strength in 7 days. Just playing in the lab, showing them, and that I think is a big thing to take into consideration. That's in a week. What is that gonna do over the course of the life of this concrete? You're gonna destroy the strength and integrity of it at that point. So, but to that, one of the things that we also have to remember is that if we have air entrainment, we're gonna see less bleed.
Correct.
Right? Non-air entrained concrete is gonna have more bleed water.
And that,
So,
sorry,
no.
and talking about the air trained interior mixes, like I said, will bleed more than the non-air mixes, as we call them. And the reason why is you have your air mixes that create these capillaries inside, so that water, stays in them, and that's basically for that freeze and thaw, which we'll, like I said, we'll talk a little bit more about too, but that's what allows it to breathe a little easier than the non-air when it comes to it.
Absolutely, and I know we've talked a little bit about the finer materials, and as far as the 1Ls and things like that. One of the things to consider is if you have, a sand that has a finer gradation, you're gonna see less of that bleed water as well. We see the finer the material, the less bleed water it needs more surface.
We have a question from the crowd.
From online Garcia, it asked if you have that much bleed water, you are adding too much water at the plant. Is it better used to using a plasticizer agent?
Correct, yeah, and we will definitely be talking more a little bit about, the admixtures, the finishers, the densifiers that will be added that can literally solve most of the issues that are happening with the 1L product.
Absolutely.
That's definitely a good question.
So, the other side of that coin though, that excess bleed water is insufficient bleeding, right? If we're not careful, and actually that's a great segue into the conversation being had, is if we're not having that bleed water because we are using a finer material, we are having lower water cement ratios, things of this nature, this is kind of a more common occurrence now, is crusting of the surface. When we start seeing that crusting of the surface, we literally start to see the concrete rip away from itself, right? I mean, almost like dried hands start to rip and crack, and it's the same thing with the concrete. If it doesn't have enough of that bleed water at the top, you're gonna start to see these kind of issues. So one of the big things that we've been discussing is things like evaporation retarders. They're hugely helpful. It allows the concrete time to do what it needs to do, which is sit and bathe in its own water, right? That's how we're gonna get the strength, we're gonna get the best surface possible. And so that's one of the big things moving forward that we're hoping to get people to understand is evaporation retarders are hugely helpful, so long as we're using them properly. And if we're not sure what that looks like, manufacturer recommendations are on every bottle, right? That's the best way to go about it. Follow the recommendations. They made it, they've done the testing with it, they know kind of the best way to use it.
Is that evaporation retardant, is that an application or is that batched in?
It's an
It's an
application.
application.
Plastic shrinkage, or 1L is very prone to plastic shrinkage. Like I said, if you're under that water cement ratio, not insufficient bleeding water, you will get plastic shrinkage on it. So
Yeah.
that's one of the main issues that I'm seeing a lot of out there. And they're asking, well, why?
Well, and I mean, so part of that is, I think, because we're still being held to the same water cement ratios, even though we have a thirstier product. So, when the drivers get out on site, they have one tool to get this what they need, right? It's water.
It's water.
And, these kinds of things are gonna happen with that. So the best thing we can do to help that out is to allow for things like evaporation retarders to protect the concrete the best way possible. The curing compounds, these kinds of things that we will be discussing a little further along. But these are the most important things that we can do, ourselves to help it.
Correct.
So,
Yep.
and like I said, the big thing is we need to remember that if we're using an evaporation retarder, that becomes water when it's worked into the surface. So if we just spray it on and we're working it in, it's no longer an evaporation retarder, it's now surface on the water, or water on the surface, excuse me. So that's just kind of one of the things that, bear in mind when we're using these things. So,
Yep, you gotta keep it moist. So,
absolutely.
as they say, I heard the saying once, it was, curing concrete basically is maintain time, temperature, and moisture. Keep those all in line and you're gonna have some good concrete.
So now some of the differences that we've seen, and again, being out there in the world, you guys I'm sure have seen these kinds of issues in the past as well, and kind of what we're seeing moving forward is the slow and the fast setting concrete, right? So the first one is, you know, slow setting. We know that the big one is temperature changes everything, and we have swings in Colorado that nobody else can play with. They can't keep up with our swings in weather here. But we know, obviously, cold concrete is slow setting concrete. You know, we should be aware that at 50 degrees, concrete goes to sleep. Below 40 degrees, it dies. It's, you know, that's just kind of a fact. It gets too cold for it to do what it's supposed to do, and there's no coming back from it, right? So one of the things that we need to be aware of is we're gonna start to see slow setting with the new 1Ls. We're discussing this. I personally have seen this happen. Some of these water reducers are acting differently. So a lot of us producers and QC and that sort of thing, we've been doing this planning and learning and what does it do? How can we help it? Things like that. But you know, not everything plays as well with one another as it used to. So that's some things to bear in mind. Then, you know, things like fly ash, natural pozzolan, that's gonna change that set time. Natural pozzolan is gonna definitely slow you down a little bit more than we're used to seeing back in, 20, 30 years ago, right? You know, it's a lot slower now. Obviously excessive water addition is gonna slow it down. Again, it's gonna take longer for that water to work its way through, you're gonna slow yourself down. And for every gallon over, you're gonna start to not only slow yourself down, you're gonna start to destroy the strength. You're breaking that water cement ratio, things like that. Real important to note. And with that is not just the ambient temperature, but the temperature of the subgrade. If we are pouring nice warm concrete on a cold day and we're hitting that icy subgrade, anybody ever heard that an ice bath? It's a shock to the system. It does the same thing. Yeah, it does the same thing to the concrete. So like I said, that's huge that we're protecting those subgrades as well as the concrete. Otherwise, we're just shooting ourselves in the foot and hoping for the best. Now on the other side of that coin though is the hot loads.
Fast setting concrete. It's definitely once it starts to get hot, concrete will start setting. It will start hardening. So I always tell GCs become best friends with Weather Channel, NOA, keep updates, what the weather is gonna be like. Now we're getting into the hotter months of the year. Fascinating if you know you're gonna be, pouring up, say in the mountains out there, and you're gonna be taking big load, look into retardant, look into that. Like I said, the name of the game is keeping the cement moist and workable when it comes down to that.
Yeah, absolutely. And I mean, to that point, one of the things that, that we talked about before this presentation also is, talk to your producers. Do they have a plan in place for things like making sure the drums are backspun? Because if not, they have that water sitting in the drum, heat's beating on it. You're now adding 5-10 degrees of hot water into a mix and starting that temperature already higher. So one of the things we definitely don't want to start shying away from are things like admixes, not just with water reducers, but also with, hydration stabilizers, retarders, accelerators, if it calls for it. We need to be aware of this, and if we're not sure, ask the producer, like, hey, this is what we're looking to do, this is what we need. What's a good place to go with it? Do we need hydration stabilizer because we are getting a warm time of the year? But again, we talked about a little bit about the Colorado weather. I don't know if any of you noticed, we're starting to get back into those afternoon showers.
Okay.
So if you're having a pour, you're like, hey, we really need to get this going before this weather comes in. Is accelerator the right answer? Sometimes, yeah, it is, even in the hot months. We have contractors regularly that are still using accelerator this time of the year. So like I said, sometimes it's the right answer.
Yeah,
So-
accelerators do set it. So
Yeah,
if you know you're gonna have a storm in the evening, look into an accelerator. 1%,
absolutely.
0.5%.
Or even other.
It'll make a
conditions, right?
Absolutely,
Or even other conditions, job site conditions, right? You're in the shade, you're in the sun. There's
absolutely.
so many things to take into consideration.
No, absolutely, and that's why, it's important, we all wanna do the same job, we all wanna have the same end result, so, don't be afraid to ask those questions, or, cause I'll be the first one to tell you guys right now, I have very little knowledge about what you guys do in the field as far as experience goes. So I can tell you guys the technical side of these things, but that's why it's so important to have that conversation, because, you may not know what I know, I may not know what you know, together we know it all, right, we know all that stuff. So it's hugely important to have those conversations and figure out if maybe it's a better solution, even though we're a little nervous.
One dream, one team. Here we go.
I like that, doing one team. You take it away? Oh. So some of the things that we do see with the fast and slow setting concrete though is, I mean, I've seen some people are like, hey, I like the slow setting, it kind of gives us that, little bit better ability to, with that window finishability. That could be a good thing, again, depending on your situation. If you fall a guy short, have somebody call out, hey, that's gonna help you out a little bit, right? So it's not always a bad thing, but it's just something to be aware of it happening. But obviously some of the disadvantages we just talked about are the weather. Being in Colorado, if you have a nice open slab or driveway, whatever you're doing, right out in the sun, it's just baking in that Colorado sun, dry, no humidity. So that's kind of at a disadvantage where you're gonna start to see that surface crusting start to be more common. So, it has its pros and cons, and it obviously depends on the situation as to which one it is. Same thing with the fast setting concrete. We've already talked a little bit about the hot loads. Literally, you can get hot to the touch, so we know that that's gonna be something that we're seeing, maybe it's starting to take off on us, things like that, it's not taking water. Is it worth, hey, let's scrap this truck, we're not gonna pour this out, let's get rid of it and try with another one. Have that conversation, don't be afraid to lose a load, waste an hour getting a replacement versus putting that down and, hey, this entire job now has to be ripped and replaced. Cause at the end of the day, we all wanna go home with money in our pocket, and that's not the way to do it, right? So, don't be afraid of these kinds of conversations, or, even better, if you guys are like, hey, I've got a little column, we could put this in, beautiful, let's do that. That way we're not trying to shoot ourselves in the foot, like I said. So, again, something that will help though is that evaporation retarder that we've talked about. Hugely helpful, especially getting into these warm months and in the hotter concrete, hotter weather, just ambient weather. So that's a huge thing that could definitely help you guys along in that sense.
And also to touch on the point of the slow and fast setting is your water temperatures, you also wanna keep in mind, in wintertime, we're using heated water, and in the summertime, we're using colder water, to keep those hot loads, like I said, without them setting when it comes down to that, so.
Yeah, absolutely. And one of the things that we're starting to see is tempering of the drums. We're using that fresh water to start tempering the drums to give us that little bit of a cool down. Helps out, these kinds of things are hugely helpful. So the big thing to remember is if it dries, it dies, right?
If it dries, it dies.
That concrete's not allowed to bathe in its own water while it's, going through its hydration process. You're gonna start seeing it cracks, start seeing it, surface crusting, all these kinds of problems. So like you said, what was it? Time, temperature, and moisture. Well, we want to make sure that we're curing our concrete.
And moisture, that's exactly right.
So one of the things that I will speak to, and this is a great image in my opinion. I saw this, I was like, oh my God, it didn't take me but half a heartbeat to be like, oh my God, I've seen this happen.
I've seen this before. That's that little piece right there is what we call a rebar.
Yeah, so, with that slow setting, though, one of the things that I personally have seen, and some of us may see, is that it allows the rebar to kind of push to the surface. And it's gonna cause cracking patterns in the form of the rebar, and actually, I think one of the slides we have in here will show exactly what I'm referring to in real life, but yeah, that's one of the things to remember. If we have that slow setting, everything just gonna slowly work its way down and, molasses its way through and push that rebar to the top. And it's gonna start causing those settlement cracks and, just the visible cracking from the rebar itself. So one of the things that definitely wanna keep in mind.
Question.
There it is.
There it is, there's that picture right there.
That's the one I was talking about. So yeah, this is on some tilt-up panels, and you guys see all the descriptions on what it was with the pour. It was 50 to 60 degrees out there. Concrete was setting slow, and you could very clearly see the pattern of the rebar in this image, right? So again, temperatures aren't wild. It wasn't freezing cold. It wasn't burning hot. Well, what did we do? NCA, accelerate that set time a little bit, kind of remedy the issue moving forward from this image. So again, it wasn't like it was middle of winter, freezing out cold. We threw some NCA in there, kind of remedied that problem. So we talked a little bit about fast and slow setting. This one is a little bit different. Erratic setting. Erratic setting is something that you can see happen from load to load, not just job to job. You know, it may be something where, you know, one driver has different eyes and another driver could cause that erratic kind of setting where we'll see one load setting slow, the other one setting like normal. So this is kind of what we're talking about. And there, you know, kind of some of the things that you could see with that erratic setting. So some of the things that could cause it is if your producer has multiple plants in the area and different materials being used, different cement materials, pliers,
Different,
things like
even
that,
different aggregates.
different aggregates. That could change your set times. So you may, you know, if we have to switch from one plant to another, you may start to see that. So it's, again, important to have that conversation with the producer, be like, hey, if this comes from here, are we gonna see a change? If we change the plant, do we see a change in the way it sets? Do we see a change in the way it's being handled? Change in materials? You know, hugely important to know those kinds of things, you know, before, and in those pre-con meetings, and, you know, hey, if we have a backup plan, what does that look like for us on the ground? You know, don't be afraid to ask those questions, because I'll tell you, from my experience, nobody's afraid to, hey, this is what we're gonna expect to see with this change and this change. You know, the more we know, the better we can handle these things. So, and it's just kind of something to be in mind and keep in mind, and also be in mind and keep in mind that if we do start to have a change in need on the ground, we may see a change in that set time also. So if we're like, hey, okay, we're pouring this huge part of it that has steps and, you know, the first part of it's here, and now we need more slump, so hey, we don't wanna do that with water, we're gonna do it with chemical. We may start to see that kind of change in set time where it's getting a little erratic till we get it dialed back in, things like that. So, you know, again, that's something to keep in mind as well. So, and these are some of the, you know, some of the things that with erratic setting that you probably wanna avoid is you wanna make sure that if you see that soft spot, work around it. You can't just work one end to the other. If you know there's been that change, we wanna make sure and check it piece by piece, so we don't have these kinds of issues where we're changing the floor flatness or levelness, right? Cause it could very easily happen, seeing guys hit it with, you know, on machine and they didn't check all of it and hit a soft spot, and now we have a nice little dip in that floor. So, just some things to bear in mind with that.
Surface crusting, well, as he's saying, it's that water that, you know, goes up to the top, creates surface crusting. I think this one is one of yours, right?
Oh, yeah, I believe that. Actually, you're right. I apologize.
But,
So, with one of the most common things that we're seeing is surface crusting. This is becoming more common of an issue with the 1Ls, these new materials that we're seeing, the 1Ls and NPs, things like that in the world. And it's because, you know, we're not checking, for one, we're not checking to make sure that we are properly, you know, ready to finish. And one of the things that we're also seeing is that because it has that higher water demand, it's starting to pull it out of the mix, right? This is one of the reasons that we talked about evaporation recovery being so vitally important. The surface crusting is gonna be the number one thing, in my opinion, that you're gonna start seeing moving forward if we're not aware of it and how to prevent it. The big one being that evaporation retarder, because it's gonna allow that concrete to bathe in itself and work all that water from the middle up. So I think that's just one of the huge things that, you know, is important to know. The middle of that concrete's still gonna be jelly-like. The surface, especially with, again, the Colorado weather we have those hot windy days, that surface is gonna start to dry up. If we're not careful, but that center of the pore is still gonna be very soft, jelly-like. So we're gonna start to see that surface crusting happening, excuse me. So that's just one, you know, something that I think the best, easiest solution is the evaporation retarders, because it allows it the time it needs, because obviously we talked about needing more time for that concrete to sit and bathe in itself. That's the easiest way to do it, the most effective way to do it.
Is that happening more with the power troweling finish than like can finish, like smaller
Yes.
stuff?
Yeah,
It's more
because
critical for that.
you're basically sealing that, causing the surface crusting, like I said, that moisture's gotta come up, once you seal it, it's gonna create even, like I said, blistering, surface crusting, all of that.
Yeah.
And like I said, to touch on the point on what he's talking about, those admixtures is, if you're a contractor, make sure that you guys are, talking about it on, when you guys are doing your quotes, when you guys are doing that, take that into account, hey, we're working with new materials. We recommend using these admixtures, these finishers, and like I said, put that into your cost. So that way, when you get to that point, to that finishing point, you're not having to put it out of your pocket or any extra surprises that you have to, let the customer know. Oh,
So, with the surface crusting, I mean, you wanna make sure that your subgrade, we talked about, make sure you're protecting your subgrade from the temperature as well. But we wanna try and keep it as close to within 20 degrees of the concrete as possible. We know that's not always ideal, nothing we do is in a perfect world, right? But as close to that point as we can get to help allow for, again, you put hot concrete on the cold ground, zaps the heat right out of it. The same thing, if you put it on a hot side, dry subgrade, gonna suck the moisture right out of it, right? So you wanna make sure you're keeping it, first of all, as close to the temperature of the concrete as possible. And secondly, you wanna make sure that if you're pouring on road base or a dirt subgrade, that you're doing it on a dampened subgrade to help allow for not only the temperature change, but the moisture change. If you're, again, one of the things that we talked about is vapor barriers.
Mm.
If you're pouring on something like a vapor barrier, you only have one way to go with that hydration process, right? Bleed water is working its way only up. If you're pouring on a dirt subgrade, it's working its way from the middle out, both directions. So, just some things to kind of be aware of that could cause these sorts of things to happen. And again, speaking of not being in a perfect world, we know some of the remedies for the Colorado wind are things like, sunshades and windbreaks. We know that's always not always a easy solution. Some of the things that we've seen is, fog sprayers. Keep again time, temperature, and moisture, helping allow for that to be in the concrete.
have any of you ever seen or used a fog sprayer in your guys' work? None of that?
I'm sure it's.
I've seen them online, but I've yet to see one that it comes down to in real life. I think it'd be.
You've probably seen them on people's back patios in the summertime.
That's about it, right? Yeah.
Yeah.
Like the same-
I've seen it, watching a football game, that sort of thing. But no,
Right.
it's
Same
not,
idea.
it's not a common thing, and that's actually a conversation that Roland and I had. While getting this presentation together, is it's not something that I've really ever seen used on a job site. So we know, again, this may not be the most realistic answer. So we kind of keep coming back to that evaporation retarder. That is the best solution for most people. Maybe not the best solution for everybody all the time, but the most common answer is that evaporation retarder. The big one is, and you guys can see it there in red, is do not work into the concrete because it become an evaporation retarder at that point. It's just water on the surface. Because most of those, we were discussing that is up to 90% water for those, evaporation retarders. So now you're just working all the chemical on, hey, just water on, just something to be aware of. Another great solution to keep that moisture in the concrete and avoid those kinds of surface crusting issues is, burlap and blankets or, just tarps.
Concrete specific
Plastic.
blankets,
Yeah,
Seen the burlap plenty of times.
yeah.
That's a real common thing,
Yeah.
is soak the burlap and throw it over the concrete.
Oh, yeah. I mean, we do it in lab for, our cylinders that we may be testing or things like that.
Gotta keep them wet.
Yeah, burlap, we have, towels, obviously, I know that's not really viable out in the field.
It's a short answer,
Yeah.
yeah.
Send somebody to Costco.
Yeah, but those are some of the more realistic answers, the evaporation retarders and the like plastic or burlap. So those are some of the better options for most people. Again, to that is, one of the things that I learned from doing this was, we talked about the dry shake.
Oh, yeah,
What is dry shake? I don't know what that is. So we consulted Dr. Google and found out essentially he's throwing cement, just powdered cement on the surface.
It's a mixture of powdered cement and sometimes it has sand, sometimes it has other additives, but you basically shake it on the top.
Yeah,
They don't recommend that. I don't recommend that at all. It's a good way to
Wouldn't
make
that
the
put more water out of
surface.
it though?
it would.
It would, yes. It would cause
Yeah.
surface crusting. It would cause A lot of that dusting, once again, it just weakens that top
Yeah.
part of it.
So, but that's one of the things that, I saw as a solution to that slow setting.
Mhm.
And so that point made me think of it, and that's one of those things that we definitely wanna try and avoid. If we need that extra cement, let's put it in the mix. Let's talk to the producer and have them add it in the mix if we need that extra. That dry shake is a hard no. It's a really scary thing to play with. Because you don't know, you may end up heavy in one spot versus another, and you're just, you don't know what you're doing to yourself at that point. So, but yeah, that was just something that popped in my head thinking, or looking at that. But again, we talked about some of the, and sometimes the answer is accelerators. You know, so even this time of year, that may be the answer for some of these issues that we're seeing, to help the entire slab kind of set at the same pace instead of just the surface being dried out by the sun or by the wind or, you know, whatever Colorado decides to throw at us that day. So, some of the things that we will see is, like we talked about a little bit, is things like NP are gonna slow that set time, and if we have that hot, dry day, it's gonna cause, you're more likely to have that cause, as well, that surface crusting, right? Because it's, the inside of it's bathing in itself, but that surface is just getting beat down on by the sun or getting, you know, dried out by the wind. So just, you know, some things to keep in mind with that. So.
Blistering.
Listening, I think he's just making me do all the talking.
Yeah, I'm thinking all the talking is gonna be you
Yeah,
for.
yeah, he's a little shy, guys, I'm sorry about that. Listening, honestly, one of the, so I will talk to this a bit, one of the big things is, you gotta think of concrete blistering the same way you would just blistering on your skin. It's literally gonna be the same kind of thing. The biggest difference is gonna be that you're gonna have pockets of air and or water in the concrete, right? So that's just something to kind of keep in mind. And this is a great example. The picture with the hammer shows some good blistering happening there. Some of these may not even be visible in a low light situation, if you're pouring in a warehouse, something like that, for example. So you may just catch it because the light caught it the right way. So something to bear in mind, they can start off 1/4 of an inch up to 4 inches, you know, these blisters. So just something to kind of be, you know, keep in mind with that. And one of the big things that causes this is more hard troweling air and train mixes. So we talked about, you know, the bleed water coming out. Well, some of that air is gonna escape as well. If it has nowhere to escape because we're hard troweling it, it's gonna be blowing up a balloon of concrete. And as soon as that happens and it starts to harden, we're gonna start to see that blistering, things like delamination, things of that nature. So, you know, that's, and from my experience, that's been the most common reason that I've dealt with blistering. But, you know, just something to bear in mind, if you have a little extra that's air and trained and you have a non-air and trained portion that you're gonna be pouring, maybe not the best thing to use it for, right? So just something to kind of bear in mind with that.
And, I mean, I've had, customers talk to, us, the producers, on if you're gonna do half inside, half outside, we can even do something with low air in it, you know, that has air for it to breathe. So, because it's about communication, talking to that producer.
Yeah, absolutely, and that's a great point. And one of the things that, you know, we also have is things to help, if you do need to pour it internally, or, you know, as an interior, you know, we have things like, you know, they're the air killers, you know, in the trucks. So if we need to, we could always go a route like that, you know, but that communication is absolutely key. So some of the ways to best avoid the blistering in concrete, I know a couple of these points are not, you know, for you guys to do, but it's the communication to be had with the producer. And to that one is things like high fines in sand. That's something, you know, your producer should be aware of. They should keep an eye on their material. So have that conversation. Hey, is this gonna be an issue? Or, you know, make sure, hey, if we see that change, let us know. Have that communication back with us, not just to the producer, but from the producer, right? We wanna make sure that if we're vibrating, we're gonna knock out all the entrap there without pushing all that, the coarse ag to the bottom and having just a nice thick mortar surface, that you're more likely to get that kind of blistering at that point. So, and the big one that I kind of beat on was that using air and train mix with a hard trowel. You know, that's just asking for problems in that sense. And this is actually the one that they really talks about the dry shaping materials. You know, that's a hard no. I think it's really important to note that's never gonna be the answer. It's just gonna be, again, asking for more problems. So I'm glad to see, I wasn't the only one that was kind of like taken aback by that one though, so.
Yeah, definitely.
Yeah, we wanna make sure that obviously, and this is the part that I speak to, you know, you guys who are out in the field every day. But you guys know how to use your blades better than I do. I could tell you, hey, it says keep it flat, and you guys know what you gotta be doing, but you know, those are some things that we wanna be, you know, we wanna make sure we're aware of, is make sure we're using our blades properly. You know, I know it says flat, is that always the answer? You guys know, you may have had this thing for 30 years and hey, this thing's tilted and it's bent or whatever it is, but it's my best float, so. You know, just, you guys know your equipment better than I do, so just something to keep in mind. Got anything?
Well, like I said, touch on that point, like all of them is the delay the trailing as much as possible, especially like I said, when we talk about the 1 out. It's just that little extra time that we ask them, hey, just wait. Promise you it'll make quite a difference when it comes down to that. Also for avoiding the high fines and fine salt, sand and ingredients, talk to your producers, ask them, hey, what's your FM or what's your latest gradation going? And they'll tell you, hey, this is going on. They should at least have that information, and then you could, you know, base your decisions off of that when it comes down to ordering from them.
Absolutely, it's a great point.
Delamination. So this one we're gonna talk about, share, because delamination is very similar to what we call scaling, and similar to blistering. So it's in between. So we had a conversation about sharing this slide, but it is usually delamination is from bleed water being trapped at that surface layer of concrete. It is trial surface. Think of it like I said, it's when you get blistering on your skin. Exactly what it is usually you pop that blister, there's gonna be liquid. Usually what happens with delaminations is that top layer, really ugly, really unsightly to see. It is usually a thin layer at the top. It's most of that, we call it the mortar paste.
Mortar paste, yep.
Mortar paste at the top that usually there's not a lot of aggregate.
Yeah. And like usually we see this in the top up to 1/4 inch.
Yep.
Off the slab.
About a 1/4 inch when it comes down to that. One of the last things it says is the separation of the surface may also be caused by corrosion and reinforcing corrosion, or freezing and thawing of insufficient air entrained concrete. That's what we talk about, getting more into the scaling part of it. Air mixtures in the state of Colorado is recommended. You know, you don't have to have ice for that. It's, I mean, what do we know? Water freezes at 34 degrees.
32 degrees.
So water gets in there into those pores, creates a ice crystal, and it expands, it contracts, and we start getting into delamination when it comes out to that.
One of the things I'd like to know with this is, delamination, mostly you can catch it if you think it's there. I know most of you guys have probably looked for a stud in the wall, right? You're looking for a stud in the wall, you hear that hollow sound, then you hear that nice deep thunk. Well, delamination kind of, you can tell the other way around. You're hitting the concrete lightly with the hammer, you're gonna hear a little bit thicker, and then you hear that nice hollow dink. More than likely, you're gonna have a nice area of delamination. So it's something to just kind of keep in mind if you think it's there. That's a nice, easy way to kind of check without doing any damage to the floor, right? So just something to kind of keep in the back of your minds.
Always see delamination as a much bigger than blister. Blister is usually smaller, that's smaller. Delamination is usually the big white spots when it comes down to that.
Yeah.
Any questions on delamination? Do not seal the surface early. Back to that, we touch on that point again. I said it's that extra time that we ask for the drawing.
Yeah. I think one of the things we were discussing is, when you think you're ready, give another 30 or 60 minutes, you know? And then I know that sounds harsh, you're like, oh God, that pains me to say it, I know, so it's gotta pain you guys to hear it, right?
Time is money,
Then
and
we
we
can
get
scrub
it.
it.
Time is money,
Again, those 30 to 60 minutes are hugely cost saver versus the rip out and replace, because it's ghastly, or, you know, just the homeowner, whoever it is mad. So the 30 to 60 minutes really it's a money saver, you know, so you invest now to save later, so.
Yep, big one too, Aaron trained when it comes down to your tier mixes, try to avoid that. It will cause elimination, and avoid placing concrete on surfaces with temperatures less than 40 degrees. It comes out.
Oh, huge one. So I know we talked about this one a little bit when we were doing our kind of our conversations, and so for me, again, I kind of go back to, you guys know your equipment best, you guys also have the manufacturer recommendations for, you know, how to do these things. So this is always the good rule of thumb to start, is the 15 degrees on your blade, right? That's what we recommend to start. It doesn't mean that that's the answer for every single piece of equipment out there, right? Some of them change. So one of the things to keep in mind is check your manufacturer recommendations. So, but the big one is that you wanna make sure you're passing perpendicular to one another. That's gonna be a big part of that, so.
Sticky concrete, this was mine.
This is all, I know you were excited about
Sticky
this.
concrete, yeah, this one, nowadays I get a lot of, questions when I'm out in the field. A lot of the GCs are, their main complaint is that the concrete is sticky. One of the main reasons I tell them it's sticky is, 1L is a much finer product, plus the sand that you're adding, other fines will make it sticky. That's what it is. It's hard to work with. Sticks to your
Your trowel.
trowel. I can't think of the word sometimes, and like I said, it's just because of that. Also, some of the admixtures that you use. I mean, I've seen high ranges. If you're using the high ranges, it'll make it stickier.
Yeah, I mean, and especially with moving into the 1L world, right? We're seeing more high range being used to get those higher slump mixes. Even into those SEC mixes, we're seeing these amounts get to the point where it's causing more stickiness. And honestly, I think we actually had to use AI to give us a better definition, if I remember correctly, to get you know, what is sticky concrete? Essentially, you're creating a more surface area. So more surface area gives you that stickiness. So it's, you know, those water reducers being used in such high ranges anymore compared to what we're used to we're gonna start to see more of that with the 1Ls and things like that in the world. So some kind of bear in mind with those. So, I know, I just want to touch on this one. It's also caused, if we have a mix that is high in air. Yeah, you know, that'll cause that stickiness as well. So if you guys are using a mix regularly and you're like, hey, why is it sticky today? You know, hey, can you guys pop an air on this back at the plant? I mean, I think there's something going on, you know, talk to us, talk to the producers. Cause that is very much something that could be happening. We could have.
Is it the admixture that's making it sticky? It's not the voids. Is it the admixture itself that's sticky?
It's actually quite the opposite. It's not the voids. There's more surface area being used, so instead there's less voids basically. And so, you know, you have without water reducers, you are having more connectivity between like your trowel and the concrete. So there's more stickiness.
More of that mortar to the.
But how does the high air make it sticky? That's what I'm asking. Is it the admixture for the air?
In that case, yeah.
It's not the voids
It's
created by the air
yeah.
training.
It's literally just the percentage of air that's in there is gonna end up causing more cohesiveness to your trowel, so it's just gonna end up, you know, trying to think of the best way to explain that.
It's like foam on top of a beer.
There you go. Yeah,
Okay.
you know, when you're taking a drink of your beer, you have all that foam stick to your lip, It's gonna be the same kind of thing.
So it's like a density thing, like the surface that you're trying to finish is a lot less dense and it's got more air.
Exactly.
So it's gonna be, you'll be more inclined to stick to the trowel and not stick to the rest of the mix.
Exactly.
Well, that makes sense.
And that's one of those things to keep in mind, if it's especially if it's a mix that you're using all the time and you're like, no, I know this mix, okay, there's something different about it, Dave, or it's sticky. Maybe you more than likely got caught with a high air on that one, you know, maybe got overdosed or temperatures dropped or something like that, all these things play a role in the air in concrete, so, you know, just something to kind of bear in mind when you're working with somebody regularly and you see that kind of instant shift, so. Back to me, huh?
Rain down surface.
Yeah, so this is actually a great image of post-tension slab from a garage that was done, I believe it was in Austin, Texas, or near Austin, Texas. And this is, you know, this is kind of some of the things that we want to touch on, again, living in Colorado, getting to the point where we're starting to see more of those afternoon thunderstorms and rainstorms. You know, this is a huge thing that is becoming more and more of a possibility, at this point, because we're getting those. And just kind of some things to be aware of when it comes to rain down surfaces. The first thing is, you know, if we can't protect it, we need to make sure that we're handling it properly. So, and then, you know, this is just a great shot of what it could come down to looking like getting that popcorn ceiling if it gets rained down enough. So just something to show. And the big thing to take away from this is make sure that you're talking to your dispatchers, your producers in general, and trying to work around that schedule or adding the admixtures that we need to help avoid this kind of thing happening. Because nobody wants to go back to that rip and replace scenario. You know, that's absolutely horrible when we could very easily avoid it, reschedule, add something in, you know, some chemical in to get it accelerated properly, things like that. So just, you know, we just thought this was a great image that was shared with us, so we wanted to share it with you guys. Because we're in that fun Colorado environment. So,
Harsh weather state.
yep. And these are some points that basically from prior to pour all the way to, hey, this got poured, it got rained on, now what do we do? Some points we wanted to touch on. So obviously the first one is be prepared for those afternoon Colorado showers, right? And what that means is, you know, maybe reschedule if you know, like you said, become best friends with NOAA and things like that. If we know we're gonna get it dumped on, let's wait. You know, it's gonna be better to wait versus having that happen. If we started pouring and that rain's coming in on us, let's try to make sure and protect that entirety of that slab with plastic to, you know, it's not gonna do us any good to cover most of it, cause that water's gonna end up going somewhere. Well, we all know where it's gonna go, cause Murphy's a jerk like that. Murphy's Law is gonna say it's going right on that concrete, right? So something keep in mind is make sure we have enough plastic to cover the entirety of the pour. If we're trying that, it's not working, you got rained on, well, we don't wanna finish that at the surface. We already talked about some of the things that could cause. So what's our best, you know, step from there? Squeegee it off the top. You know, try and get as much of that water off the top before we continue with our finishing procedures. Now, that being said, we took all these steps, everything, you know, it was just that great day that everything went wrong. What can we do? Well, I mean, depending on the situation, we have the option of kind of grinding down that surface and giving it a nice, you know, that open aggregate look thing, you know, that's kind of a solution versus ripping off the entirety of it. And again, that comes down to the requirements. If we're on a big commercial job, probably not gonna be as feasible as if we're doing somebody's, you know, sidewalk to their front door. But just some kind of options that we have out there available for us when we do have these kinds of issues happen. So.
Tearing it out would be the last step.
Absolutely, the last step.
Full concrete would look nice.
Yeah, and I will tell you guys, I've actually seen some homeowners who've ended up with that kind of situation happen where they have to grind down the top surface and it gives it kind of a cool look. So just personal experience, so. Oh, this is all you.
Is it?
Oh, yeah, you wanted this.
Let me see, double check. Well, we'll talk about random cracking. Plastic shrinkage cracking. This is one of the big ones that I do see this a lot, especially with the 1L. It is very prone to plastic shrinkage. One of the things that I always tell my contractors are spacing for your joints. Sometimes they do joints weirdly. Sometimes they do designs and it creates these weak spots and it creates random cracking. Sometimes it could be the surface, the subgrade, sometimes there are multiple issues when it comes down to, or variables when it comes down to random cracking. Overloading the slab with heavy equipment, also.
You do, especially if it's, you know, if it's still early on.
Yeah, if
You
it's
know, if it's not ready for to be in production.
2 or 3 days, if you don't have a high early mix or anything like that, and you're driving your semis, you're putting all that equipment in, that would also create cracks, random cracks, but you know, it's not so random because you drove a big semi or.
Well, I know, we, one of the points that we talked about while doing this was, everybody talks about all the different kinds of cracks, you know, there's plastic shrinkage, there's craze, all these different things, and one of the things that, I believe JT made the point was, there's really only 2 types of cracks, right? What do we say, it was like plastic shrinkage and then random, is really all there is.
Yeah.
So, you know, that's just something to kind of bear in mind, all of it is just, it's an umbrella form, or, you know, a way of saying cracking. It's gonna be random, because if we don't tell the concrete how to crack, where to crack, when to crack, it's gonna tell us, this is where, when, and how I'm gonna crack. So it just becomes random at that point, so I just thought that was kind of a cool point.
Even your curling, when it curls too, seen it when you have different temperatures, you know, top, bottom, they start to curl, your slabs. I mean, we've seen that in warehouses where it even creates hazards. I mean, you're driving a forklift, imagine a slab about this much high, you hit those forks, you're gonna do some damage when it comes down to that. So once again, I'd say is that spacing in between those slabs or the joints is gonna make a big difference when it comes down to that. So joint spacing, it says, is 24 to 36 times the slab thickness. And the proper saw cut that is 1/4 of the slab thickness.
Yeah, and one of the things that I know that I was actually unaware of this moving into it, like I said, I told you guys that I'm not very well versed as far as flatwork finishing goes in practice. I know it in theory, not in practice. But the thickness of the slab when you have the steel reinforcement, I learned that when doing this. So, you know, but that is definitely something that kind of took me aback. I was like, oh, okay, I've always just known it 1/4 of the thickness. No, you go as much as a 1/3 if you have that steel reinforcement. So, you know, just something to kind of bear in mind, especially with those big kind of commercial jobs or, you know, things like that. Just something to kind of keep an eye out for with the specifications. So that one, just little point that I'd like to throw out that, you know, I learned doing this.
Yeah, 1/3 of the slab thickness, I did not know that either.
At what point does random cracking call for remove and replace?
That is a case by case situation, I would say, obviously.
Honestly, I think it kind of comes down to, kind of much like the rained on surface, it kind of, you know, can we save it without, you know, without having to do that whole process, but absolutely, case by case basis, in my opinion as well.
Is it structurally sound?
Yeah, exactly.
If it's structural, what's it,
Yeah, and
what's
I
the
think,
placement, what's it doing?
yeah, and I think that's the definite answer is if it's structurally unsound, I think at that point where you have to do, you know, rip and replace kind of situation. Before that point though, if anything prior to that, it kind of depends on the situation.
It's almost cosmetic, right?
Exactly,
Correct,
yeah, you maybe add some more cracks and, you know, give it a nice spidery look to it or something.
You like the crocodile look?
Right, the rattlesnake.
I'll just interject real quick, and it's like, there's a reason we saw cut, there's a reason we create joints, because concrete's going to crack.
Absolutely.
And it's like, just because it cracks does not mean it is bad concrete, does not mean it is less structural. That is something that you have to determine depending on the pour.
Absolutely.
It will harden and it will crack.
Those are the 2 guarantees in concrete.
There we are, some good pictures of some random cracks.
I think this one's kind of important to know is when you start to have those kind of, those different, you don't just have a clean monolithic slab, you have to account for the jointing of it properly as well, not just the depth or spacing, but kind of where do they go, right? When you have a joint cut like that, you know, do you need to put that extra cut into it coming off the corner? I think that's something that's kind of important to know and to, you know, to be aware of, otherwise you're gonna, again, if we don't tell concrete where, when, and how to crack, it's gonna tell us when, where, and how it's gonna do it. So,
Oh, some good pictures. I-25. This is right by, as soon as you exit,
yeah, I get to run over there on my way home.
There you go. You're the one that took these pictures.
Shh, nobody, don't tell anybody.
So this picture basically shows a good example of, you know, the cuts not cut fast enough. They waited a little too long and this is exactly what happened, so.
Yeah.
Cracking.
Yeah,
Exactly like you said, if we don't tell it what to do, it'll do it by itself.
Yeah, that's what I was about to bring up, because it's like random cracking is just that random, uncontrolled, and it's like, if we can control it, the better. And it's like, and doing those saw cuts at the appropriate time, knowing where to put that reinforcing steel at corners, whatever it may be. And it's like controlling where those locations are.
Yeah.
You're gonna see less, if any, random cracking.
yeah, and I mean, well, hell, they're called control joints for a reason, right? So let's control them, you know, I think that's a huge part.
Craze, spiderweb cracking, what we talked a little bit about, the new term that I heard was crocodile. So.
Yeah, that was new to me too. Roll came to me with that one today. I was like, I've never heard that one before. I've always just known it as either craze or spider cracking. So that was fun.
And like I said, usually these cracks are surface, at the top. They don't, they're aesthetically, they're unpleasing. They're ugly to look at, unless you're into it. They are not, like I said, they don't put into question the
integrity.
of the concrete. I'm having a hard time thinking today. Maybe difficult to avoid craze cracking on hard trowel surfaces, so.
I think to that point, one of the biggest reasons is, you know, if we are timing ourselves properly with that hard troweling, we're gonna, you know, we may cause some of that bleed water that we talked about to be trapped in there, and we're gonna start to see you know, this sort of thing happen. Again, you think about, just a basement pour, and if you're gonna hard trowel it and, you know, we have kind of different setting or something along those lines, then we're gonna see something like this happen. I think that's why it's more common, with the hard trowel surfaces versus not, right? So.
Usually, like I said, the top layer, that part, you work it, you overwork it, you dry it, and that's where you get this beautiful pattern. To minimize craze cracking, like I said, do not work that bleed water into it. Let it evaporate and then jump on it. Give it a little bit of time, back into that. Our whole presentation usually is give it time, give it time. It's one of the main points.
I know one of the things I'd like to kind of bring up here is, I know water is necessary, but it's also kind of the devil when it comes to concrete. It causes the ability to create, you know, the second most used product in the world behind just water itself, right? Concrete is hugely used worldwide, but, you know, water could also be very, very destructive to concrete in so many different ways. And I think that's one of the reasons we do these kinds of presentations. It always comes back to the you know, the water being added, the water not being worked in, things like that, not blessing the concrete. So that's just something that, you know, it's just that fine give and take of concrete. We needed the water for the concrete, we overuse it, and we've just destroyed the concrete. So it's a fun game to play, it's a fun balancing act.
And like you said, back to that, the blessing, I've even read stories of guys grabbing their hard hat, grabbing some water and then spreading it all over. It's like I said, adding extra water to that top, blowing that water to my
It's like our number one problem, with no matter what contractor we use in the city, just like we tell them over and over, don't do that.
Don't
do that. So you turn your back up. If you don't know what you're doing, all you can think is, this makes it easier for me. You know, a lot of problems on the site, it's just the guys who are doing the work, like, well, this makes it easier for me to do, but you're not thinking down the road.
Yeah.
Or even right now, what you're doing to it.
Yeah.
Have you ever worked with somebody that over jitterbugged it or?
Actually, honestly, recently, I had to deal with an issue with somebody that, Jitterbug is a great tool, don't get me wrong. But much like a hammer, it's not the answer to everything, you know, so using the jitterbug or, you know, even the roller bug, if you're overusing it, you're just pushing all of that coarse aggregate to the bottom, and you're just asking for that cracking to happen. Cause it's just gonna be all mortar on top, all aggregate, coarse aggregate at the bottom. So, yeah, I actually did deal with that recently, and that was a fun conversation to, hey, this is kind of what happened, and well, I've been doing this for 30 years, and okay, I get that, we're moving to a new world, folks. So, you know, Aladdin said it best, a whole new world, right? So, but yeah, it's just something to keep in mind, that they're great tools if we're using them properly. And, you know, you don't wanna use a hammer for, you know, to try and get a piece of window into the wall, right? It's not the right tool, it's not always the best tool, but it's a great tool to have. Just something that in my mind is something that should be remembered is, yes, it's a great tool, it's not the only tool. So that's my take on jitterbugs and roller bugs, so. I know one of the things that we actually didn't touch on, I did want to, is the curing. That is huge, we wanna start that as soon as we're done with the final finishing, right? That is huge point, and that we almost skipped over because I went on my little tangent, so I apologize. So, but yeah, that curing is hugely important. We can give you the best concrete in the world, if it's not cured properly, it's not gonna come out for crap, right? So that's something to bear in mind. I know we've touched on it a little bit with things like, you know, covering with burlap and plastic, things like that. But starting it as soon as we're done with the finishing process, hugely important. So,
Time, temp, and moisture.
absolutely. The saving my phone is roll, time, temp, and moisture.
That's it, time, temp, and moisture.
This is actually a kind of a cool picture for me. I know we talked about it when we were having our conversation. This is a pond curing.
Puncture, yeah.
I've never actually
curing.
seen it done in real life. So, you know, when I got to witness this, I was like, oh, that's kind of neat, great idea. It's a great way to go about, you know, curing a slab. Again, if it's done properly, right? We wanna make sure those temperatures aren't gonna vary more than 20 degrees. I know it says, you know, cooler, but again, if we're in Colorado, that could change, you know, this afternoon. So just something to kind of think about there, and the big one being not to let it dry out, because at that point, it's, you know, it's not a pond curing situation.
Concrete will definitely set underwater, so
Yeah.
that's a pretty good example right there.
Yeah.
Discoloration, this is dark light spots, even up to what I would call the efflorescence, in this slide. Usually is caused by, you know, overworking that paste at the top, even sometimes using, like you said, the burlap when you lay it down, some spots will be darker than the other ones. Changing plant, say for example, one plant delivers this concrete mix, and then they run out of trucks and they order from another one, even their aggregate. Adding calcium to the mix can discolor.
That's a huge one, no, absolutely. One thing that I did want to touch on though with that, covering it with plastic or burlap. So you guys actually, I don't know if you guys can see that image real well, but you kind of have those dark and light spots. If we're covering that, we want to make sure we're doing it, you know, evenly across the board. If we have those kind of like, just those humps in the plastic, we're gonna start to see some of that discoloration, right? So that's part of that. So, you know, just something to kind of bear in mind with that.
Right, like you said, I don't know if you've ever seen overworked concrete throughout the years. They will get really dark spots and you can tell, oh, they overworked that paste on there. It's one of the big ones that I see mostly and ask. Efflorescence, we want to talk a little bit more about it in this slide, is basically that water going through the dryness and creating these, I don't know if you've seen like these foamy white spots. You see them a lot in like parking structures. Recently had a customer that I got called out because their driveway had some efflorescence. They told them it was gonna be fine, a couple months, it was gonna dry out, but that dried out and it created these ugly white spots that just made some ugly discoloration.
I know we had a situation similar to that. It was a giant wall that we had to deal with, and, one of the things that, can be considered is if you get that fluorescence, it's not to an extreme, you can power wash. And that would kind of help, kind of remedy that sort of issue, so, again, talk to your guys' producers about, like, hey, this is what we're seeing, can you guys come out, take a look, help us out with that sort of thing? I know me personally, I'd love to get out of my office and step out into the real world a little bit more often, so hopefully not problems that happen that often, but
Just to learn.
exactly, always learning.
This one's dusting. The most common cause of concrete dusting is carbon dioxide in the air. Usually signs of dusting on your flatwork is proof that your surface is weak. That first surface is weak. Usually you should be able to see it even by stepping on it or sweeping it. That white dust that comes up, that's part of what we call dusting. It's chalky and if you walk through your house sometimes with your shoes on and your partner will yell at you, that's all that dusting, but.
Every day I come home, so I actually, for me, this picture is very reminiscent of me being in grade school and, saying a bad word in class and having to write that. I will not say this bad word in class 100 times on the chalkboard. Every time I see this picture, just like, oh, no, please, it just kind of brings me back to that, but.
One of the reasons we wanted to talk about dusting, specifically in the winter time, some of the GCs want to help out and they bring out these heater vents.
The salamanders.
Salamanders, yeah.
Kind of image there.
Kerosene, diesel. Or what it does is, if you don't have the proper ventilation and you have the dusting with those salamanders, it creates maybe what we call it a poisonous.
Yeah, so CO2 poisoning.
CO2
right?
poisoning.
And actually, while we're putting this presentation together, one of our colleagues brought up the fact that he went to a job where they were using these and everybody just kind of seemed very lethargic and, kind of blotchy skin and just kind of like, ugh. And they didn't realize that that's what was happening. They didn't have the proper ventilation. So again, for one, less important, you're more likely to cause dusting. More importantly is you could have somebody get CO2 poisoning and fall out, even die from it. So, yeah. So huge safety concern for that one as well. So, just something to bear in mind with that.
So, yep, keep that in mind. If you're a GC and you're out there, you wanna, bring some heat to your guys, make sure windows are open. I know it's, I would say counterproductive because you're, counterintuitive when you have that cold getting in, but let them know it's, because we don't wanna poison you guys.
Yeah.
So.
Is there a time limit for the dusting and the fossil fuel heaters? Is it like after a certain amount of time, is it okay to use them without?
So, I mean, generally, once you've been cured, you should be better off, but by that point, this is more so for like day of the job.
Yeah.
You're trying to keep that subgrade warmed up, that you're doing a big, warehouse, something like that. If you're having that, you wanna make sure first, you're not directly on the concrete, because that's where you're gonna start to get that dusting more likely to happen. And, again, for the safety aspect, for me is you wanna make sure to have that ventilation for the guys, because that could take anywhere from, just a couple minutes to an hour, depending on, situation. And, one of the things I will talk to with this one is, I had somebody actually ask me, like, well, it was a driver, and they asked, hey, we did a job where we had to back into a building, and they had a pump in there and everything, could that do it? Yeah, you absolutely can. They're like, you could see what they said, you could see the smog in the air. Well, absolutely, that could very much cause this issue. So it doesn't just come from the salamander heaters, it can just any kind of CO2 in the air can cause that sort of thing.
That reaction to it.
Yeah.
Curling and warping, basically going back to that, upward, downward edges that tend to curl up or down. It is usually horizontal. Going back to my example of, we see this a lot in like warehouses, where they start to curl, they create that uneven surface. And say you're driving a like I said, a forklift, you hit that with the forks, you're gonna flip over, even tripping hazards, and this is usually caused by, what we call the thermal, moisture and temperature in the surface, so usually the subgrade is different temperature than what's on top, and that's what's creating that either upward or downward, curl when it comes down to that slab, so.
Yeah, I equate this to, you know, when you burn a piece of paper, obviously you see it as it starts catching fire in the corners, you're gonna see it curl up. Cause that temperature's gonna change more drastically. So, and this is actually a great example of it, you know, just what that looks like, but yeah, you start to get that curling when that temperature's between the subgrade and the concrete, it varies, that sort of thing can absolutely cause this curling, so.
And going back to like I said, the spacing of the joints matters. Smaller the spacing, the more curling you're gonna see, bigger slabs have more weight, so takes care of that.
Absolutely.
And scaling, going back to scaling, looks a lot like the lamination. It's basically what we know as the freeze and thaw issue. When those ice crystals get inside the pores of the concrete, they expand, they contract. Once they expand, they create that push out that concrete, creating the weak, what we would call the weak paste, weak blisterings that will start to degrade over time, and this will keep on going. Another of the issues that scaling is caused by is our the matte chloride. Matte chloride, especially in the state of Colorado, we have you know, they spread it all over the roads.
Yep.
You drive your car back home, and one of the big signs that you usually see when you see scaling is you look at the driveway and you see those tire marks going all the way up to the.
You can see right where they pulled up.
Exactly, right where they pulled up.
But
I've
it's a
seen.
bad load of concrete.
I'm sorry?
Oh, yeah.
But it's a bad load of
Yeah.
concrete.
Yeah, but it's a bad load of concrete, yeah. I've even seen somebody say, well, I'm not driving there. It's a big spot right in the middle, but do you park there? Yeah, I park my car there. Usually from that engine, dripping, and then also so hot that it melts the ice if you drive, you know, on top of the snow on the ice, so that's some of the good examples of scaling.
Absolutely. One of the things, especially because we do live in that freeze-thaw state, another common cause of it is air entrainment. If we don't have proper air entrainment, we know we're gonna get some of that scaling happening, right? So, yeah, I know here it talks about scaling mainly caused by the acid salts, and you'll see it on bridge decks and, no, I've seen it everywhere. You know, so it's just kind of something to bear in mind, you know, we wanna make sure that we're using that air entrained concrete for exterior uses, so we can avoid those kinds of things, so. I do know, like, one of the points that I do want to touch on is the minimal flow finishing. When we have that, you know, just hit it with the bull flow, or hit it with the float, hit it with the broom, let it do its thing, you know, it knows what it needs. So, something to kind of think about when we're doing that. I don't know if you were assigned this one or if I was, to be honest with you.
Talk about it. Curing,
Yeah.
time, temp, and moisture.
That's what I'm saying. I feel like this is your wheelhouse, right?
Yeah. Basically, you know, without sufficient moisture, hydration will not occur. Without hydration, concrete cannot attain the desired strength. So like I said, keep your concrete moistured. If it, once going back to that slide, if it dries, it dies when it comes down to that.
It's okay, you can say it again.
If it dries, it dies.
I was saying time, temperature, and moisture.
Oh, time, temperature, and moisture, that's right, when it comes, that's my favorite sentence now.
Yeah, honestly, to this point though, like, if we kind of touched on it a little bit, we can give you a great quality product. If it's not cured properly, it's for naught, right? So that's just something to kind of bear in mind. So, because not only, one of the things that going back to a training that we're doing with our drivers is we showed them what that kind of over water use can do. And one of the things that we're trying to get them to educate on is not only is it gonna ruin your strength, it's also gonna ruin your permeability. Right, you're gonna start allowing more water into the middle of the concrete, and you know, it's just gonna start ruining it because we already know the concrete's weakest from tensile point. So something to kind of think about that, if we're not curing it properly, we're not allowing it to do what it has to do, hydration process, it doesn't matter what we do to prepare for that job or, moving forward, it's gonna have to be redone, right? So just, curing is really, really important.
Consequences of pure curing. Poor curing, more cracking and curling, crazing, alligator map crazing, cracking as we call it.
I like that one, that's gonna be my new one, is
The
alligator.
alligator one, yeah. Erosion and wearing away from surface, and definitely the one that we always look for are, the big issue is low strength.
Yeah.
That is something that is not gonna hold up. So those are some of the consequences of poor curing.
Yeah, and like I said, especially if it's a mix, it's designed at 4,500 PSI, didn't get cured properly, we're not anywhere near that. Makes sense, right? And I know that's kind of one of the big ones that we've all kind of learned over the years is strength. Strength. So if we want to have that good strength, we want to make sure we have those good curing practices.
We go back to the curing compounds, the finishings, the finishers. One question was asked, how much should we be adding to finish the concrete being poured? We always tell them, go to the manufacturer of that finishing product, go based on what they're telling you, they tell you specifically, apply at this time and this much. So I say, always go back depending on what you're using. So there's a ton out there. Like I said, we don't talk about specifics, but there's a ton out
Yeah,
there.
there's a lot of different options, and I know that these are some great kind of points to use as a rule of thumb. And again, like Raul said, always want to go back to the manufacturer recommendation, right? But we know we want to do a continuous film. We want to get the best coverage we can. So, we want to make sure and do it from two different angles, from perpendicular angles, make sure, as far as, what is that 1 gallon of this particular curing compound do? How much does it cover? That's a big part. You wanna go back and check your manufacturer recommendations. Cause if they're saying, hey, it's 1 gallon to 5 gallons, and you're throwing 5 gallons to 5 gallons, at this point, we're just throwing water on top, aren't we? So.
Water and money.
And another big point, and this is something again that came up for me not too long ago, is we wanna make sure that we're using it properly if we have that color, the color concrete. Is this gonna be good to use on a color concrete, or does it have to be just for plain gray concrete? Something to bear in mind, and ask those questions to the manufacturers as well, so.
Sealing, so curing and sealing, two different things. Sealing is what we recommend after the concrete's been set, after all said and done, is to basically extend the life of your concrete. Sealing your exterior concrete is a minimum of 30 days after it's been poured. Some people like to wait a little longer, but based on the ACI standards is 30 days when it comes to that.
I do know that, again, for me, big point is that we wanna make sure it's done prior to that first initial freeze though. So that does get a little bit tricky again in Colorado where, hey, we're getting into the winter months. So is it 30 days? Is it free, before the first freeze? And that's actually a point that I wanna bring up JT and kind of get your thoughts on that. Cause I know I feel like that can be kind of butting heads with itself. What are your thoughts?
You need to protect the concrete.
There you go. I like that.
That's bottom line. You need to
Okay.
protect the concrete, be it blankets, coverage, ceiling, because the curing process on concrete is not just a 1 hour, 2 hour process. It is a week, 3 weeks, months worth of process. And it's like concrete continues to gain strength over the lifetime. So, and it's like that initial curing is still, can be a few days, it could be a week, it could be a couple weeks. And it's like, so you've got to make sure that you're understanding that product that the producers are providing. So, and it's like, bottom line, protect it.
There you go. I like that answer.
And this is something the GCs should be also letting the customers know, hey, seal it, and also every 3 to 5 years, reapply that coat. It's gonna extend the life of your concrete for years to come. It definitely helps.
Absolutely.
Perfect, we stand.
Yeah, we survived. These are some great references, that, made available for anybody who has any more questions or any more, wants to go a little bit more in depth for what some of the things we've talked about. I will tell you guys that for me, I think the concrete practices, the CIPs, they're generally two pages long, and they have a lot of great information in just those 2 pages. That's one thing we talk about, we still go back to them, ourselves.
They're a little older, but they still work.
Information
today.
still holds up.
Exactly, yes.
So
Great
just
basic information.
Absolutely, it's, great way to get just that, hey, why did this happen, how do I prevent this particular thing? So just something to kind of bear in mind, and I know I have them readily available for my customers if they ask, so I'm sure most of your producers do as well. So if you guys have questions on those sorts of things, don't be afraid to ask, or, see what that looks like, but yeah, for me, that the CIPs are a huge help. When
CRMCA has a handful,
CRMCA, yep.
it has a few of them as well, yeah.
Yep. Oh,
So in summarize, minimizing the defects. Don't add too much water to the mix. Don't finish the bleed water into the mix, don't work it in there. Do protect it from the rain and the first snowstorm and all that good stuff.
Yeah.
Don't bless the concrete. We say that do not add that water to that top. It's not gonna do anything good.
yeah, just remember, we're not in church, we don't bless the concrete, right? That's not for us. So another big one that I feel like, we could have made this one stand out a little bit more is the curing. Make sure we're curing that properly. Cause that's gonna give us a nicer product for a lot longer if we're doing that, properly. And then, of course, we wanna make sure that we're not putting it into use before it's ready. If we need something that needs to be in use early on, again, communication is key. Talk to your producers, let them know, hey, we need this in use 24 to 48 hours. Great, we can do that. Don't just use any old, hey, I've used this before, it'll be fine. It's asking for problems. So allow it to gain strength. If we do take all these steps, properly, we're gonna minimize a lot of these issues moving into the new 1L world. So just some things to kind of keep in mind.
Perfect.
And these are some of the things that we're expecting to see more issues with, speaking to new materials, we're expecting to see obviously the set time slowing down. We're expecting to see more common things like surface crusting happening if they're not handled properly. That's the key part of that, right, is if it's not handled properly. We know that it's a different material, the way I always tell people is, this is not your father's concrete. Just like phones have upgraded in technology, so is concrete. And that's something that's huge to kind of bear in mind, that a lot of things that we've spoke to today will help minimize a lot of these issues if we handle them properly, if we use a lot of these steps. Again, evaporation retarder being a huge, easy solution for a lot of people. That's a big one that I push on, because a lot of people talk about how, well, that's probably the best way for you to go about doing it. Absolutely. So
If you follow the instructions.
yeah.
If
as
you
long
follow
as-
the
again,
instructions.
if-
Always refer to the
I will go back to
manufacturer,
that,
that's right.
if done properly, exactly.
Perfect,
Alright,
all right.
any questions, thoughts, concerns?
At this point, I would invite everybody that's online to unmute yourself and it's like have a conversation and ask questions as well. And it's like, don't leave it into the chat.
Yeah, absolutely.
Hopefully we didn't take up too much of your time.
Oh, you guys did a good job.
Hopefully we didn't bore you guys too much either.
That's what I wanted to say, but.
We're still awake, we're all
No,
awake.
okay, good.
You did good.
To that point, I won't speak for anybody else, but I am readily available for anybody who needs, has questions or thoughts, and, my email's up there, feel free to reach out. I am down in the Springs, but I'm more than happy to, answer any questions if you guys need. I'm more than happy to step in, even if we're, if you guys are up here in Denver, that sort of thing. Don't hesitate to shoot me an email.
Same also myself, I'm up in the northern part, so if you guys are ever up there, have any questions, please let me know, my email's right up there. and help you out with it.
And I'm everywhere.
And you're
Yeah,
everywhere.
JT wants to join us.
We're gonna get over to eat.
So, well, with that, thank you guys for, presenting this content. We will be, sharing this, and on, YouTube as we have with our, last Tech Tuesday presentations. And also these guys will actually be translating this session as well as a couple others into Spanish for online distribution. So please do share that information as appropriate as well.
That's very cool.
So thank you guys very much. Appreciate it.
Thank you guys.
Thank you everybody online as well.